Okay, so here we have Kinetics Quiz 3. One question. Here's our geometry. So kind of a tetherball type of thing. Not just one chord, two chords. And it is not... it is staying at a constant speed, going in a horizontal circle. So that means that it is not gaining or losing any elevation. It is just constantly going around a flat plane. So that means tangent acceleration equal to 0, but it does have tangent being anywhere along that plane, but it is accelerating inward. So, and we know that normal acceleration, or radial, is equal to the velocity squared over the curvature, or instantaneous curvature. That curvature is equal to 2.6. We also know that this is one chord, so the tension in it is the same throughout, around both parts. So, here we have a little free body diagram. We are given angles. So, this guy's equal to 30, that guy's equal to 48. Again, we know that tension is the same, it's just different angles of attack. Then the only other force of the ball is the weight of it. And we are dealing in metric units, I believe. Yeah, the ball is equal to 5 kilograms and 2.6 meters. So what we can do, we need to find the tension of the wire. We can do that using sum of forces in the y direction. We know that there's no acceleration in the y direction, so we can set that equal to 0, as I said there. And we have three forces. We have ACY, BCY, and the weight of it. And we know up here that the tension in BC is equal to the tension in AC, so that equal to that again. So AC equals BC, so we just have tension ABC. And so we have tension ABC. So if we drew a triangle anywhere, we have theta here. We are looking for that component that is equal to the, hypotenuse cosine theta. So, because theta's up here, so it's the one next to it. So it doesn't really matter which order we put, because tension is the same in both. Then is equal to the weight, which is the mass times the acceleration, or gravitational weight of gravity, or force of gravity, acceleration of gravity. Then do some more algebra, take the tension out, and then divide by that on both sides, and we get the tension of ABC is equal to 31.95 newtons, which makes sense, I guess. Because, both parts, have parts going up, or tension pulling it upward and such, so if it was more than that, one of these, or both of them also have side components as well. It's not pulling directly upward. If it was more than, or very close to 45 newtons, or nearly 50, I'd question it quite a bit more, but again, tension working in multiple ways. Now that we have our tension, we can find, or we have the necessary piece to find the velocity. We know that all the forces in the x direction cause a normal acceleration, again, or acceleration going inward. And we know that is equal to the mass times the velocity squared divided by the instantaneous curvature. And we only have two forces in the x direction. Here's our little scale. Positive is that way. So we have BCX plus ACX is equal to the m times v squared over the curvature. Again, doesn't really matter, but this time we're using sine because we want this part, which is apart from over there, is h sine theta because it is opposite over hypotenuse. So, do a little bit of algebra here. Say, we'll just double check work again. 31.95 times sine 48 times sine 30 times 2.6 divided by 5 square root. We get 4.54 meters per second, but we are just going to one decimal place, so velocity is equal to 4.5 meters per second.